I'll go.
We'll try not to do that one too much. Okay, good afternoon, everybody, and welcome to MASQUE at IETF 120. I think this is the first time Eric and I have managed to be in the room together to chair, so better late than never. It's good to see all of you. If you're not already signed in with the blue sheets, please do so we get such a big room for the next meeting. We're early in the week, so please bear in mind this session is being recorded. You should be able to use the queue to join, enter, and so on. I'm sure many of you are familiar with it. In terms of the note well, please remember that the IETF's patent policy and various terms and conditions apply. You are participating in this meeting at the IETF. Please keep in mind the need to work respectfully with the other participants, and if you have any issues, the link to the Ombudsman is there. We have a fairly standard agenda today, but does anybody want to make any comments or changes or suggestions or alterations? then I think the next thing is we need a scribe. Does anyone want to volunteer to take notes?
Well, you are very interested in your laptop. Now would be a great time to open up the Meet Echo session to make sure you actually signed in.
I think Watson has volunteered in the chat, so thank you, Watson. And without further ado, I think we can get into the first presentation, which is QUIC Aware Proxying by Tommy and Eric. Yep. That's been approved.
Okay. Oh, I see. You did the thing where you gave me control of your slides.
Let me kick you out.
Yeah.
There you go.
Confirm. Okay. Hello, everyone. I'm Tommy Pauly from Apple, and I'm co-authoring this with Eric Rosenberg, also from Apple, and David Skenazy from Google. So this is QUIC Aware Proxying. It's one of the documents we've had adopted for a little while now, and we've discussed for longer than that. I'd like everyone to appreciate the new logo for this sub-protocol. QUIC hiding behind a mask. Okay, so this should be a relatively short update, but there are a couple open questions we can discuss. So first, the status of what has changed in the recent versions. So since IETF 119, we've published 2 versions because we're overachievers. So version 02 is a large change that incorporated the design team output, which we had discussed at the previous couple meetings. This is where we add the scramble packet transforms so that we have less obvious fingerprintability and recognizability between packets in forwarded mode across both sides of a proxy. So this version, if you look at the difference between 02 and 01, it is just incorporating that. That's about packet transforms, and it's about security considerations. Version 03 incorporates one more substantive change, which is addressing the looping attacks that Martin Duke had brought to light and horrified us all with. And the solution that we went with there, based on the discussion on the GitHub issue and previously in the meeting, was adding another capsule. So essentially now the proxy is responsible for assigning a virtual connection ID to the client, and then the client acts that, and that solves the loop problem. Additionally, this version, I spent a lot of time reorganizing the entire document. It had grown organically over time. It was long, it was confusing, it had overwrought terminology. So hopefully it is clearer now. So before I talked about sockets and other things, so the general terminology is currently using is that we have our client, proxy, and target, as we did before. We discuss having the client to proxy for tuple and the proxy to target for tuple to represent those sockets on either side of the proxy. And then we have the end-to-end client to target connection. The document now, if you look at it, has this terminology section, but then has more of an overview section where it describes who are the different players in this, what are the different things that awareness of quick connections over the proxy grants to the proxy the ability to do, and goes through some examples before it dives into the nitty-gritty details. It also separates things out, so there's a section of like, here are all the capsules that we have, and here are the headers that we do. So it's hopefully easier to digest. If you think it's good, let us know. If you think there are still things to improve, which I'm sure there are, please also let us know in issues or on the list. Okay, so moving on to some of the open issues and discussion that we're having on GitHub. Just wanted to get people's input here if we have any opinions. So we have two different issues, which from my understanding of them are really about how do we handle preferred address and what that can trigger for clients needing to migrate. And so from my understanding, the issue here is that we have the target server, which is a QUIC server you're talking to. It can send a set of preferred addresses back to the client and say, client, please migrate over to these addresses. But we're going through a proxy. We don't control what address we connect to. Generally, if we're connecting by name, or we don't own that proxy to target for tuple. So the client is learning the preferred address, but the proxy doesn't. The proxy is the one that actually has the connection to the address. And this is something that actually applies to normal connect UDP. It applies to either tunneled or forwarded mode equally. So it's just a general problem. But I think the issues are correctly for this document, because since this document is about trying to improve the behavior of a connect UDP proxy for end-to-end quick connections, you need some advice here for how do you proxy QUIC better. So there are a couple different options. At a high level, you can have a situation where the client just opens up a new connect UDP request for the target address, and essentially to the proxy, this is a completely unrelated thing. You could have something where you try to use capsules or other signaling to tell the proxy about the preferred addresses, or you do something else. So do we have thoughts? Do we have opinions? Ben? I know, also I'll comment that Christian Huitema had, I saw some back and forth there, and I've not caught up on all of the details on the issue.
Ben Schwartz, Meta. I think we should tell clients to do whatever they want.
I love that liberty.
Mike Bishop, Akamai. My inclination is that the proxy doesn't really need to care whether these are the same connection or not. Yep. Unless there's some reason that I'm missing that the proxy needs that awareness. I think just a separate connect UDP request to the target endpoint. If it succeeds, you've migrated. If it fails, oh well, you still have the original connection.
Now, I may be incorrect here, but I think the one thing that may be relevant is if the client has connected by name, and if the proxy is not adding something like a proxy status header, the client may not even be aware of the address that it used to connect. Mm-hmm. So potentially, someone remember, for preferred address, can it include the address that you ended up using, or is it always a different one?
Well, there's no point if it's the address you ended up using.
What?
So the target scenario for it is I did a connection on Anycast. Now I've landed on a server, and that server has given me its unicast address.
Yes. So
there's really no point if you're not changing endpoints. Now maybe you're changing ports, but the server is just going to send you an IP and port and say, I'd really rather you be over here.
Fair enough.
I think we can just keep it simple and move on.
Yep. Okay.
Alessandro Godini, Cloudflare. Yeah, the whole capsule thing seems like it would add a lot of complexity that is not necessary. So like,
I agree.
Unless someone has, a reason why just creating a new request is not feasible, then we should just do this simple thing.
Christian Huitema, I already mentioned that on the issue itself, but I think the Connect UDP is the right solution. Mm-hmm. In particular, because you may want to use a different proxy for the other address.
You could.
So it covers all scenarios, and it's simpler to implement.
Okay, good.
Mira Kuleman. So I actually agree with Ben. I don't know why we need to say anything here. Like, what's the benefit of providing any kind of guidance? I mean, I agree, using a different connect is probably the best solution and straightforward. But like, why do we need to even give guidance about this?
Right, we could certainly leave things out. We do already have text around, like, what do you do around migration? And maybe we can include multipath, which is not really changing the protocol, but just giving advice to like, hey, clients, when you get this and you're doing quick connections over Connect UDP, this is the recommended thing to do.
Okay, Magnus Weston Ericsson. I agree with that. Let's just go with the Connect UDP direction, and I think it's might be worth saying a little bit about, but not go too much into everything. I think this belongs to this. Yes, it's nice to know or clarify. It maybe should have been in the Connect UDP RFC to begin with, as something to think about. But yeah.
Alex Shanowski, Meta. I think I agree that we should probably just keep it simple, but I do think we should have text here specifically because of the question you just brought up, Tommy, of what if you're connecting by name? And since we support that, I think we should just give guidance of like, if you're connecting by name and you get one of these things, it is still your responsibility to connect by address if you want to do that. So I'm in favor of the clarification.
Yep, that makes sense. Okay, I think we have a good way forward here. Thank you. Oh, nope, we don't have a good way forward.
Yes, but, I mean, this is general guidance. Why are we putting this in this document?
Well, so, I mean, at this point, like, normal Connect UDP, I don't think, does it say really anything about what is the UDP application on top of this? Like, exactly, like this, so far this document is, the QUIC aware one is like, here is what it's like to proxy QUIC over QUIC.
Yeah, okay. I guess QUIC is the only transport that supports migration, but it's not like so migration is a general concept. So
yeah, I feel like this text is, it's not normative. It's just describing something that can happen and what a reasonable way to handle it is. Okay. All right. So next we have an issue. If Eric Rosenberg, are you online? Do you want to speak to this? Because I think some of this is
sure
proposals you had. Thank you.
Yeah. So after the client has sent that Connect UDP request and capsules are being exchanged, a number of connection IDs may get registered. And so one of the questions that came up was, should we limit the number of concurrently registered connection IDs? Some proxies might have a limit themselves to prevent like resource exhaustion, but should proxies be advertising some limit, or should they just be sending a closed connection ID capsule when they say registration that would exceed whatever their inherent limit is? So interested
and
in any
for the limit, what would you propose the mechanism for communicating that limit to be?
I think something like offset based comes to mind, giving credit, kind of similar to how we do flow control in QUIC, as opposed to specifying like a concurrency limit. And that could be done through capsules. So as capsules get registered and then closed by the client, additional credit could be issued. That seems potentially a complicated solution to what would be an otherwise simple closed capsule, like no, you registered too many. But yeah, interested in folks' thoughts.
All right, Antoine?
Antoine Franco, Huawei. Regarding, I think limiting CID registrations is a sound thing to do to prevent resource exhaustion on the proxy. I would favor a credit-based mechanism for doing this limitation. Like for instance, on the first request, the client could request a credit, and this credit would be in the form of tickets that you consume or coupons that you consume for each and every registered target CID. And if you need other, you request them to the proxy, but this is a way of limiting the amount of resources that can be consumed at the proxy. And I think it's a very sound thing to do to avoid attacks on the proxies.
Mm-hmm. Yeah.
Yeah, Mia Kulevind again. Yeah, I think we should do something. I think I would just propose to do exactly the same as we do in QUIC for CIDs and copy the whole mechanism there where you publish them and retire them and you have a limit and so on. It sounds like a big machinery, but we know how it works. We can just copy it and do it.
Cool. Ben.
Ben Schwartz, I was going to say the same thing as Miria. Also, just an idea. We actually already have those numbers on the client to proxy link. And so we could possibly just declare that they also apply to the virtual connection IDs. Specifically, we already have the active connection ID limit transport parameter on the client to proxy QUIC connection.
I think one key difference, like even take away anything about forwarding or VCIDs, let's say it's just about registering the CIDs so that you can do port sharing. That's a case where like it's merely about the end-to-end connection IDs going up, and it's not like it doesn't seem like it's consuming the same pool. Like
No,
it's a
not
separate
the same
pool.
pool. But the interior and the exterior QUIC connections are independent, but they're also coupled in different ways. They need to maintain the same wire image in some for some of our privacy properties, for example. If you want to be
For
able
some forwarded mode stuff, but not for all possible cases.
Okay. Anyway, so we already have an active connection ID limit on the client to proxy link. We could just say that's also the active virtual connection ID limit and avoid having to define new headers and stuff.
Yeah, okay.
Kazuhoku, my plus one goes to what Miria said. I prefer having something like flow controls like thing, because in other models we've had security issues like rapid reset attacks and those things.
It's good to learn from the past. Martin, you agree wholeheartedly with Kazuho? It's a good thing to do. Okay. All right. So, Eric, I'm going to ask you to write some flow control text. Okay. And then last, I think this is a pretty simple one. There's the client VCID, which is the virtual connection ID that is chosen now by the proxy, given to the client that the client receives on for the virtual link. This is currently a should, that that the length of this connection ID should be at least as long as the actual client connection ID. There's a missing ID at the end of the sentence, but ignore that. Should it be a must? I think it probably should be a must. Does anyone see a reason that it shouldn't be?
Are you certain that you always will know how long the SID is? If I start the connection and other migrate it to the proxy, then you will never see a long packet.
So this is a case where the client has registered the target CID.
Okay, yeah. Mm.
Yeah, and so it just has to be as long or longer than the CID that the client already registered in the capsule.
Yeah, okay. Mm.
Yeah. Okay, I think we'll just make it a must. All righty, I think that's it. So the authors will work on those updates. We'll see you in the issues. And please do read through the editorial reflow and let us know what you think. Thank you.
Thank you, Tommy. And great timing, yeah. Next up, we've got proxying listener UDP in HTTP by Agit.
keep changing the name.
Hi, everyone. My name is Abhi Singh, and I'll be presenting Mass Connect GDP Bind. And this is a draft I'm collaborating with David on, David Skenazy. So, quick recap what it is. Oh, Connect GDP, but now we can bind. So you can listen on the proxy on behalf of the client from any target, from more than one target, as opposed to regular Connect GDP, where you have to define one. So this is this is enabled by setting the target to the to asterisk and providing the Connect GDP bind header. So what's new is we've added support for target compression. This was an issue which was open for a while, and I want to thank everyone who was involved in the discussion. And we're introducing two new capsule types. The first one being the compression assigned capsule, and the other one being the compression closed capsule. And the compression assigned capsule is used to allocate context IDs to targets, and compression closed is to release said context IDs. And so the compression assigned capsule, what it will contain is a context ID, even number allocated by the client, odd number by the proxy, and either can request compression of a target via this capsule, and once the other party confirms by echoing back this capsule, they can omit the IP information in each frame and instead just provide the context ID per frame, per QUIC frame. And when this IP version field is set to 0, an uncompressed context is requested. So to explain what uncompressed contexts are, so once I've set IP version to 0, any QUIC frames on that context ID, once it's been negotiated, will need to contain the IP version IP address and UDP port in each frame. So effectively, this context can be used for any target. This means we're open to listening from everywhere and anywhere. And so, but only the client can allocate these. So the client has full control over if it wants to listen from any target or not. And then there's the compressed context. So Tommy Polly came up with kind of a very neat concept here, which is we're using the context ID to compress a specific target. So for a given context ID, it's mapped to a given IP and port, and from here on we can just omit this information from all the QUIC frames as long as the context ID is valid. And yeah, so the compressions can be sent, and like officially, like you need to wait for the confirmation, but you can preemptively send QUIC frames, but note that you might drop some of them, and this is fine behavior for UDP. And so the other capsule that I mentioned, which is compression close, so this can be sent by either the client or the proxy, and they can use it to clean up or close connections, and it's for if the proxy wants to do resource management, that works too. Yeah, Alex, go ahead.
Alex Nahovsky, Meta. Hopefully this is a simple clarifying question, but are these IDs able to be reused?
So at the moment, no. But is there, sorry, go ahead, David.
Well, I was going to say, I hope the answer is no, because it makes life a lot easier, because I was really worried if we do allow reuse, you have a whole class of race conditions.
Exactly, and that's why we didn't, we chose to not have that as a
David Skenazy, yeah, we decided that in 9297, that context ID won't be reused.
Yeah.
In that case, maybe close is not the right verb. Yeah, like, I'm not here at the bike shed, but I think we just need to make sure that the text makes it clear that we're releasing the resources associated with this context ID, not the number itself.
Right. So yeah, so this compression close capsule can also be used. So like when an initial compression assign is sent and the proxy is unable to handle more context for resource management reasons, they can reply with a compression close to reject this request from the client. And the client can do the same thing. And as mentioned, like this achieves two goals at once. The first being compression, so it saves the IP port tuple information in each datagram. And the next really neat thing is IP restriction. So you could, the client could initially open to, it could be open to listening from any IPs, but once it's identified who it wants to talk to, it could close that specific context ID that's allocated to only the uncompressed ones. So, and it can just have its own compressed channels to talk to the specific UDP targets, UDP target IP and ports that it cares about. And so it kind of lets it act as a firewall. And so this is the second thing that, the second issue we closed, which is the proxy public address header. And effectively now the proxy is required to send the proxy public address, which is the IP and port tuples that it allocated to the client in the response headers for the initial connect-UDP listen request, a connect-UDP bind request. And multiple ones can be provided per address type. And so there were some discussions on the mailing list about this. Should we allow more than one per family? We did decide in the draft that we should, because, well, if we're trying to replicate how it works on a machine, you can have more than one, and I think it's fair enough to be able to connect to like multiple subnetworks. And ICE WebRTC have already dealt with these problems before, and they're designed to work with multiple candidate IP addresses. And so if anyone has any stronger opinions on this, please let us know. The other thing is identifying which proxy local address gets used. So at the moment, we're letting the proxy pick its own proxy local address for a given target. So the client isn't specifying which of the specific addresses it wants to use. The proxy will pick for itself. And so we were wondering if anyone has thinks if there's any benefit to letting the client consciously pick which of them to be used. Ben Schwartz?
I think this can be addressed as an extension later if it's needed.
Right. Is there anyone else? I don't think so. So that was my last slide. So these are all the changes we've had. And I really want to thank everyone for, it was quite the discussion, and we've made some really good developments on this. Jonathan Lennox.
Hi, Jonathan Lennox. Seeing these two presentations in a row, I think that Connect UDP Listen and Quick Aware Proxying do not work together. And is that a problem? So we need a third extension to support that, running a HTTP server through MASQUE or whatever. Okay.
Yep. Well, I guess that's that, unless anyone else. David? Yeah.
Sorry, David Skenazy, just as co-author, before we jump on from this topic, I think from memory, and Abhi, correct me if I'm wrong, these were the last open issues.
Yes, that's right. We don't have any other open issues on our draft anymore.
So what I would propose would be for the editors to do an editorial pass on the document. And then how do the chairs feel about potentially doing working group last call?
Ooh, Tommy just jumped into the queue. And then we will talk about our feelings.
It's related to our feelings. I just wanted to ask about like implementation status and testing status. So like I know like I had implemented like an earlier version of this with not all your recent changes and tested and used it for stuff I would like to update. Have you implemented this version? Have we tested it with WebRTC through a proxy? Like it'd be nice to do that and get some results before we ship the document or move to last call.
Totally agree. Abhi, what's the status of your implementation?
Yes, I was going to say, I had implemented, again, also the same thing, the previous version, but the newer additions that we merged in are yet to be completed. So
awesome. So how about we start like finishing implementation in parallel, we do an editorial pass? Because I think as we're implementing, and then once we get interop between at least those two and anyone who would like to join for the fun, and then once we have that, then potentially we'll talk about working with last call.
Yeah, that sounds good. If anyone wants to also do their implementations and test with us, I would love to invite people to participate with us.
Yeah, and I'd love to encourage some of the other proxy server operators to implement this so we can test it out.
Awesome.
All right, before we let you go, we did have a couple of questions to help us guide this process. So one of them is just who's read the draft, for which we you get to dig out your phone and scan that QR code if you haven't yet. But I put an asterisk next to recent, so we're not being too picky here. But I think an editorial pass will be good, and also any other comments that come in as people do that. The follow-on question to this, as you cheerfully tap yes or no, will be kind of who's got an implementation, who's working on it, would be interested in coming to a hackathon or interoping outside of a hackathon, things like that. So I think we want some of that deployment experience as we go, and it's nice to hear that we've got multiple implementations that are preparing to make sure that we can interoperate. But it'd be nice to make sure that we've got everybody represented wherever we can. All right, we're going to close this one down in a second. And for your second poll, do you have an implementation? Are you working on one? Are you interested in working on one? Really, we're looking for, if you click yes here, at some point, come talk, and we'll make sure that everybody can find some time to do a quick interop and make sure that everything's working. So this is a chance to get somebody else to help make sure that your implementation works super well. All right, thank you very much. So it sounds like we've got some folks who are either working on one or have one already. So let's get the existing ones interoperating and make sure that we reach out to the new folks and help welcome them.
Perfect.
And I see Zahed has joined the queue.
Jahed, I didn't get the feel like the 6 people said like they have implemented this one. It's like one implementation or multiple implementations. So yeah, so who are the others who has implemented this one?
Oh,
okay. Good, we have multiple. That's what I wanted to know. Thank you.
All right, so like reach out to me either after or on the mailing list, however you like, and we'll figure something out.
And we're happy to help coordinate there too. So
awesome, thank you.
Let's all chat.
Perfect.
Wonderful, thank you so much.
Okay, next up we've got Alejandro with Ethernet proxying over HTTP. take us away. Do you want us to do the slides for you, or do you want to control?
Should be able to request them from there. I can't decide if I want to control them or not because I've had problems with it before.
Request control, and we can always.
Yeah.
Ask slides.
Yep.
Those slides. If it goes silent, I'll confirm that. So back again with more Connect Ethernet, because yay layer 2. There's been a bit of work on the draft. We have closed a bunch of issues that had been discussed in previous meetings. I'm not going to go into too much detail here because we've closed them. We have some new issues that we've been discussing on GitHub around VLAN tagging and client configuration, what versions of Ethernet we support, and issues with layer separation for congestion control. So for VLAN tagging or client configuration, we have text where we're recommending that if you're carrying multiple VLANs, you should carry them over separate connections. Though you can carry VLAN tagged frames in here if whatever you're dropping them onto is capable of dealing with that. But we didn't describe how you might differentiate those connections when making them. And when we borrowed a lot of the text from Connect IP, we stripped out the URI templating language because we had nothing to template. So I'm thinking we should put that back and allow you to name networks potentially. I'm also thinking naming networks, not numbering VLANs so that you can decouple things. So you can make a connection to your IoT VLAN if you want to, and you don't need to worry about what it's called on some physical segment. Any thoughts here? I see a bunch of thumbs up. I see even more thumbs up. Hooray. Cool. Oh, and Watson is in the queue.
Quick clarification, or maybe make us too far into weeds. You're saying you have a name and that VLAN's going to have a number across all the places you're linking up with this, or is this saying we translate the name potentially differently at different ends?
I'm going to go read the transcript for a moment because I didn't quite catch that very clearly. So when you're naming a VLAN, I'm thinking you're carrying untagged frames, and they're going to be dropped onto an interface that's on a VLAN, and you don't have to worry about whether or not the tags match on either side. It might not even be tagged on one side. It's just you're making a connection and getting an interface on a network that could be tagged on the other side. And if they have names, like, you have a way of indicating which one you want without having to worry about what the actual tag number is. Does that answer the question?
It does. I'll let other people discuss whether or not they want that. But thanks for the clarification.
And nothing says that you can't choose to name the thing, 5. If you want to name it with the number of the tag, have at. But I don't want them tightly coupled. All right, and then there was a question of what exactly do we mean by an Ethernet frame, which seemed pretty clear, but we had no normative language around it.
if we need to specify it, I think we should just say 802.3 Ethernet 2 frames and leave it at that. There are also some other like weird and little used Ethernet standards that we probably do, or maybe not even standards that we don't need to worry about probably. Magnus?
Yeah, I mean, I just think we need to, I think this is fine. Do a normative reference to the Ethernet 2's frame specification. It's, I guess the only question is like if there's multiple versions, etc. But I guess there's hopefully some sequence of compatibility here in Ethernet for this, because otherwise it wouldn't have worked. So I think it's hopefully probably fairly flexible. But yeah, need to find some, figure out what that exactly reference is.
So I think we do have a commitment to go back to the IEEE folks at some point about pretty much exactly this issue. We can do that proactively if we would like to. But if it doesn't make much difference, then it can be something I guess we sort out at the final stage.
Yeah, if we want to do that sooner and just confirm that like specifying Ethernet 2, IEEE 802.3 and whatnot, or how they would like us to specify what we hopefully all agree on is an Ethernet frame, that'd be good. And then there was a question of layer separation and congestion control.
Just very quickly, I think we should go back to IEEE when we are in working group last call and the document is ready, so we don't like ask every time a little question.
Right. Right. And then layer separation and congestion control. An Ethernet proxying endpoint might be able to do some clever things with regards to whether or not it wants to do congestion control related stuff or not by looking into the frame. I don't think that the protocol should make any claims on this front. But if we have people who want to suggest some text that could go into an appendix that indicates like, hey, here are some things you could do if you wanted to, but they're not required, I might be okay with that. This goes back to what we discussed in 119 where we were talking about MTU and TCP MSS clamping and whatnot. Like you can do some inspection of the packet, but I don't think we need to.
When you say these should not be too detailed, like, are we trying to help people get pointers to what they would go look up for how to do this? Or are we just like saying, by the way, this might exist, good luck?
I'm thinking like, if we want to take for instance the TCP MSS clamping, I don't think we need to go into like the full details of how you do that. Like you can look it up. We might want to say more than just like bullet point TCP MSS clamping, but not like fiddle with these bits.
Got it. Thank you.
And that's about all I've got.
Kenji CMCC. I have a question regarding the Ethernet frame. I think in one slide is showing you're going to get the Ethernet frame from very beginning up to the FCS. Yes, that's the one. If for some implementation, the original FCS being stripped off, will that affect your protocol?
Well, the frame that we're carrying currently says that it should carry it. If it's been like what has stripped it, we had another issue about whether or not we should bother carrying it or if we should just strip it and regenerate it ourselves, which.
Because I can give you a scenario in the 5G S, there's the Ethernet PDU. And then it specifically ask, basically in the specification, it says that one will be stripped off, yeah, at the source. And then it's going to be sent to the, whatever receiver. At that moment, that does not have the FCS of the original Ethernet frame. So, yeah.
Yeah, so we might need to rework the language around here.
Okay.
Anything else?
So I think as we start to wrap up some of the open issues here, we kind of want to ask the same question, but a little bit earlier of, hey, who's read this? Please read, please provide reviews, please provide comments. I see Julius has just joined the queue.
Hello, I'm a little bit confused. So looking at the introduction of this document, the protocol is used in order to connect devices that only speak on link, right? That's what your introduction says. And now you're speaking about VLANs in the protocol. So I have the feeling that the introduction needs expanding in order to explain what the protocol is meant to be used for.
It could be. It's been a while since I've looked at the introduction.
Thank you, sir.
Was it going to be hold? Should I be up here for that or what?
I think you're good. Definitely do take the chance to read, provide comments, provide feedback, all that kind of stuff. I think once we close out the last couple of things, we'll ask the same questions that we did about Connect UDP bind and that stuff. So who's implementing, who's interested? If you don't have an implementation and you think you might have one soon, we should chat. If you already do, we'd also love to chat. All right.
Okay, David, take us through DNS configuration for MASQUE, which is definitely not DNS in MASQUE.
Man, spoilers. Can you present and then I do the next slide, please? Thanks. All right. Good afternoon, everyone. Happy Tuesday. My name is David Skenazy, and let's chat about DNS. Next slide, please. This is definitely not DNS over MASQUE, indeed, because I kind of presented this last meeting when I had just submitted the draft that morning. So as you might say, I crash landed that presentation, and that was unclear. So we have way enough mechanisms for sending DNS these days. We don't need yet another one. This is not what this is. This is when you have a Connect IP tunnel that allows you to exchange IP packets and configure your IP addresses and your IP routes. Let's talk about configuring DNS. So conceptually, etcresolve.conf and POSIX. Next slide, please. And this is something that all the other VPN protocols have a way to do. If you look at IKV2, there are messages that you can exchange that allow you to configure that. If you look at OpenVPN, it has this. And in particular, like the way we chose to design MASQUE was more similar to IKV2, IPsec, and OpenVPN, where the configuration is done in band in the kind of key exchange protocol. Whereas if you look at something, let's say WireGuard, they just said, hey, here's the tunnel, and then you run DHCP or RAs over it. That's just not the choice that we did for MASQUE, or for Connect IP in particular. And especially when you have folks that are using IPsec today and have decided that MASQUE Connect IP is the great future and amazing answer to all the problems you've ever had in your life, they realize that this becomes a problem. Next slide, please. So the way Connect IP works today, we use capsules to exchange address information. So for example, you connect to a Connect IP server, you can say, hey, I would like an address, please, and the server can say, here you go. And those are always bidirectional because it allows you to do network-to-network connectivity. This isn't rocket science, that's also how IKV2 and a lot of other protocols work. Similarly, we have a route advertisement capsule that says, for example, in some cases, it's you can route all your packets through me, or in some cases, it's I'm only giving you access to this prefix because that's our corporate network that I'm giving you access to. I'm not a full full tunnel VPN. And so when we wrote Connect IP, RFC 9484, we thought in the early drafts we had DNS in there, and we decided, okay, we have enough problems to solve. Let's punt this to an extension. This is that extension. Next slide, please. Because right now, the only way you can do this is by exchanging it out of band. You connect your MASQUE tunnel, and then you do something else in your protocol. You write it on a Post-it note, take a plane across the world, hand it to your server operator, and then they type it manually in etcresolve.conf. It's not the most efficient thing. Next slide, please. So instead, big surprise, what's the answer? You shove it in a capsule, and that way you can do it in band. Next slide, please. The just rough idea for this draft, just to have a demonstration that this is possible. You have capsules that are kind of mimic the way address assign and address request work, where you can request DNS configuration and you can assign it. And every name server has an IP address and some other configuration. You can configure it to say, these are the domains that I can respond to. Like, let's say if this is a corporate VPN, you could say like, anything under corp.example.com, send through my DNS server, the rest go to your regular configured one. Same for DNS search domains. So yeah, at the end of the day, again, not rocket science, looked at what IPv2 did something conceptually similar, just encoded differently. Next slide, please. One of the things that I didn't have last time that was rightfully pointed out is the year is 2024, the future is now. We want DOC, we want DOC, wow, I managed to forget DOE on this slide, well done. All of the ways to proxy DNS. And I updated the draft and added kind of a type var and say, hey, it's this one. Got some good feedback of, please don't invent yet another way to do this. We have ways to do this with the HTTP or with these DNS service records. And then like these two RFCs tell you, use the kind of same format for doing it in DHCP, for doing it in IPv2, then let's just do that format. I actually haven't written the PR to do that, but I'm totally on board. Makes sense. Happy to not reinvent something. Yeah, next slide, please. Because they use conceptually the LLPN and other parameters in the SVCB record to configure everything you need. And that's kind of all there is to it. It should be a pretty short document, and I think it's kind of one of the pieces required to make Connect IP useful. What do people think? Oh boy. Hey, Ben.
Hello. So this is an important problem. It's worth solving. This is like a step in the right. It's a step that would solve the problem. But
oh no, he said but.
I really think that this is the wrong layer to solve this problem. The right layer is tricky. It's an interesting question, but I think that to solve this, we need to take a few steps back and start from a different question, which is basically what is the bootstrap point for a MASQUE deployment? What is the thing that I am broadcasting out to my fleet? Or what is the thing that I am encoding in a QR code? What is probably a string of ASCII characters that gets down to the device that starts the whole process? And this kind of presumes that that is a Connect IP template, or maybe a Connect UDP template. That's what I see here. I don't think that's quite right. I think that we need to think a little bit more carefully about what that bootstrap string is. The reason I don't think those are great choices for the bootstrap point is that I think we actually want multiple protocols. If you're using QUIC, then you probably don't want to be using Connect IP for all of your QUIC connections out. You probably want to be using Connect UDP. You might even be wanting to use one of the QUIC optimized variants of Connect UDP. But you want Connect IP because you also want to be able to do totally general IP. You want a functioning VPN tunnel that gives you full IP connectivity. So you need IP and UDP. And you also have TCP tunnels. Unless you want to run TCP over Connect IP, which is much less efficient than using Connect TCP, then you want Connect TCP as well. So so okay, our bootstrap string could be a collection of these things, and I wrote a spec for a JSON blob that would give you all of these things and would also give you a DO server. And so, that's one approach to solving this problem. Or another approach is maybe provisioning domains are actually the crucial solution here. And what I give you is a provisioning domain URL, and then all of these proxies and DNS services hang off of it. But I think we need to step back up and figure that out before we figure this out.
So yes, and. So I totally agree that there is a deployment model for MASQUE that is the kind of Swiss Army knife of proxying. Exactly what you described, which is exactly what the cool kids at Apple went and already implemented. The idea that you're involved so deep in your networking stack and you have one of those cool kids user networking stack where you can do everything you want with it, that, oh, you were about to open a TCP socket? No, just do connect. You were about to open a UDP socket? Just do connect UDP, so on and so forth. And for that use case, totally with you, that's the right answer. But that's not the only use case for MASQUE. Like, we have cases, even for Chrome and Chrome OS, where our stack isn't quite this cool yet. I would love it to be this cool. Working on getting funding to always make things cooler. But in practice, what we'll do is the way Chrome will be configured is the world you're describing, but the way Chrome OS, which is underneath, will be configured, expects an IPsec tunnel and needs still this configuration for the low-level parts of the stack. So while I totally agree with you that we should keep working on either PVD or JSON, I think that's the right general idea. I still think there's a need for this as well, as clearly demonstrated by some use cases.
I think that actually in the Chrome OS case, this would be confusing, maybe even a recipe for disaster, because what you'd end up with is a situation where you have your rich configuration, which goes to Chrome, which has one DNS configuration expressed embedded in it, and you have then a different pathway for DNS configuration, which flows into the underlying operating system, which means that depending on which application you're using on the same device, you're doing DNS resolution to differently configured servers, potentially to different servers, and getting inconsistent behavior. I think it would be a lot, in that architecture, this is not a very hard technical problem. You run a local, a DNS stub forwarder, like systemd resolved, and you just point it at the DNS service that's identified by your high-level configuration. Your resolve.conf says localhost. This is how my corporate laptop is set up. So
wait, and how does your local DNS resolver then know where to get this configuration from?
So yeah, I think it's outside the VPN is the answer, right? Machine device
that's what this
configuration
is.
is not in the VPN. You can't configure a VPN from inside the VPN.
Well,
You need to be able to bootstrap from below.
No, but what you need to connect to the VPN is which server I'm talking to and what credentials do I have, and then you can do the rest kind of bootstrap from there.
So basically, I would say, you should run a localhost forwarder. Your DNS queries should bounce into Chrome's DNS resolution stack.
There are multiple reasons why that's not. So anyway, I agree with your architectural vision in general. I'm saying the practicalities of many things don't quite work for that, because and today, what I'm describing is what they're doing with IPsec, and they would like to move away from IPsec, and without this saying oh no, just do the full architecture and feed the packets into Chrome. Great long-term plan, not going to happen yet.
Even then, I think that you can just do that, right? The system doesn't understand what Connect UDP is. Okay, the system ignores the Connect UDP specification that's bundled in your general spec. As long as it specifies a DNS server and specifies a Connect IP tunnel,
but
that's all you need, and it can ignore the rest of your complicated config.
The DNS server is only reachable through the tunnel, though.
That's fine. This is a bundled thing. So, this is the bundled configuration. Anyway, that's
all right.
Thank you.
That's helpful.
This is Watson Akamai. This is just a clarifying question. So if you had a DNS server that you only wanted to make available over the tunnel, you're just going to advertise the address as the DNS server to use, and that address is in the routes that the tunnel is provisioning.
Through this, yes, generally that would be the idea, yeah.
All right, Tommy Polyapple. So partly to respond to the conversation Ben had brought up, I think this is very different from the Bootstrap case we were referring to. Bootstrap is what we were doing in the PVD draft that's adopted in int area about this configuration. Like you start with the name and use what can this do? Adding in, does this thing offer a DO server on my relay is cool. That makes sense. And that effectively comes down to like sending a separate request to the proxy server itself of a different HTTP request of like, tell me your config about all the things you can do. And maybe one of those is DNS. And like, that's not what this is. I think it may be useful in the definition here to explain exactly how narrow this is, because I don't even think it's relevant to all types of Connect IP. Like in Connect IP, we define like there are different flavors. Like sometimes you're doing it just so you can ping a host. You would never do it for this. This is only for the like VPN use case where you are trying to replicate an IPsec tunnel, which is like one of the 3 flavors you have of Connect IP. And so making it very clear for that, I think would help.
Just to quickly answer that, totally agree. That is narrowly scoped, and happy to make that clearer in the text.
Then the other thing I came up for, and this is maybe it's a little bit too goofy, but if you do want to kind of get down the road of saying, oh, but you know, what if my resolver is just running on loopback on the same machine? It could be interesting. Like I definitely want to encourage us to move to the format that is the encrypted, that supports encrypted DNS. And once we do that, if the name of the encrypted DNS server supports H3 and H2, and it is the same name as the proxy that you are talking to itself, you could say, well, yes, of course you can reach me through the tunnel over IP packets, but if you would like to just send me DO, like I am the same origin, and that's okay. It's an optimization.
So that's goofy, but I like goofy that's already in the draft.
Okay.
Alex Shanhowski, Meta. I heard the discussion that Ben had, and honestly, my reaction is, why not both? I think that these are not incompatible. They're, at worst, orthogonal, at best, complementary. Right? I think the bootstrapping problem that Ben was talking about and that Tommy was talking about is one that's worth solving. And if you have a DNS resolver there that is useful, great. But also, I think the capability that this adds is, what if you have a different bootstrapping mechanism? Maybe you're doing something out of band and you still need to convey this information. You can still do that. Or maybe your bootstrapping information is stale and you want to do some additional capabilities there, or load balancing. This set of capsules gives you a lot more capability in addition to the full split horizon VPN use case. So I think I'm in favor of this from that perspective. I'd like to see this work go forward. I do have a security considerations question. We were just talking about, we expect these DNS servers to be reachable over the tunnel. And I think we probably should say, and maybe I just missed this in the draft, it's not a big deal if it's a DO or DOT or DOC server if it's not in any address range inside the VPN, but it's probably really bad if it's a traditional DNS 53. So maybe we should consider, if it's not already there, talking about what address and what interface server would be reachable for and what the right use case would be here. And I think that is something that isn't currently addressed by the provisioning domains, because I don't think the provisioning domains currently have the granularity to be able to talk about within the tunnel, outside the tunnel by design.
Yeah, that makes sense. And whereas here, because this is so scoped to the tunnel, it makes perfect sense to say, this is your DNS configuration, send that through the tunnel. And I think I'd have to double check, but V2 has some similar text when they're doing the same thing, and happy to look at that, bring it in. Yeah, that makes perfect sense.
Thank you.
Thank you. And to go back to your first point, like totally agree. This is like a very narrow scope to one aspect of Connect IP, and I don't want it to take away from the other, like all the things, because it is, again, very different. So yeah, that's the end of my slides. What do people feel about potential adoption? I don't, how many people read the draft? What do we do?
Can I just ask a question? Josh Cohen, himself. So understanding what this is, so is this kind of like the information that comes back from DHCP, like on a regular network, that comes back for an IP tunnel over MASQUE?
That's exactly right.
Okay.
Yeah, I think seeing as we talked about this previously and then now, we've gotten a couple of good pieces of feedback. It might be worth, grab a meal with some of the folks who had strong opinions there and see if we can coalesce down into some path forward that everybody's excited about. I think the other alternative there is, if we aren't going to try to solve additional problems, make it super duper clear how narrowly we scope some of these things. But it'd be nice to at least get everybody fed on the way there.
Thanks. Yeah, absolutely. And I'm happy to clarify the scope. It was always small in my mind, but that just never made it into the draft.
Hey, Lars Eckert, Mozilla. You should probably take a look if the charter allows you to adopt this, because it doesn't say anything about DNS at the moment. Just sort of to preemptively, we don't want to be surprised later on when we all think we should do this, and then we realize, oh, the charter is actually not written. So maybe check that now.
Absolutely. Thanks. I will make sure to run this by our responsible AD.
Actually about to talk about that.
Because I think from memory it says extensions to connect IP, but we can double check that folks on the ISG are happy with it.
That's all.
That's all.
All right, in our last couple of minutes, I'm going to use this mic in the hopes that it's better balanced between remote and in the room. So if I'm too loud or too quiet, just shout over me. So I wanted to take a couple of minutes to talk about kind of what's next for MASQUE. We've seen that several of the presentations that we talked about here today have issue lists that are getting shorter and shorter, which is a wonderful thing. Especially thank you to the authors and editors. That means that we're actually making progress on documents. Fantastic. We've also got a substantial number of people who are reading and participating and commenting, so thank you for doing that. There's a checkpoint coming up as we enter last call for each of these documents, where it is a really great time to take another read through and provide your feedback. There's a reason we call it last call. So let's do that with each of the current set of documents. But as we wrap those up, I thought it would be good if we took a moment as a group to talk about what's next. So one of the questions, and this gets to be a slightly more interactive part of today, is who's actually deployed MASQUE somewhere? Somewhere can be the Raspberry Pi in your house. It could be to a bajillion customers. There's a whole spectrum here. We welcome all. We do work to prioritize here. But yeah, so I saw a couple of hands go up. How's that going for everybody? I see some thumbs up. I love thumbs up. So one of the things that we wanted to talk about was some of this real world deployment experience. Do you have comments about how it's scaled? Do you have performance measurements that you'd like to share? These aren't things that you have to get up and shout at the mic right now, but in the next couple of meetings, we wanted to take a little bit of time to say, hey, we've been doing some of this. We've got folks who have actually shipped this to customers in the wild. Let's talk about how it's going. Let's talk about the problems that you ran into. These don't necessarily have to be drafts that you write up with solutions to these problems, although I hope that you've solved them. And I know some of us have all talked about ways to solve some of these problems. But really, it's mostly let's bring some of those conversations here. And as people have ideas, then maybe we turn those into extensions, or some of the things that you've done might update some of the existing documents, things like that. So really, how's it going? Did it work well? Did you discover that when you had more than 10 clients who tried to use it, it all fell over and everything melted? There's a wide spectrum of things that can have happened. Were there things that were really confusing as you were reading the documents and you couldn't figure out whether this particular value was supposed to be inclusive or exclusive of something else? We seem to miss that one a lot when we specify things. So this is a moment to pull in some of that feedback. Let's talk about some of the performance metrics. How does this actually scale when you try to do this at internet scale, things like that. That seems like both an interesting thing and also something that guides some of our future work. So if anybody's interested in presenting any of that, please do contact Dennis and I, and we can help coordinate and make things go there. We're not asking for like any super internal secrets of things, more just kind of in aggregate. How's it going? Is it working for you? Is it not working for you? What could we potentially do at the IETF to help make it work better for you or for others who are going to follow in your footsteps later? Sound good? Sweet. The last piece here is Lars hopefully brought up our charter. We are chartered to adopt. Oh, I got his ahead.
Yeah, so I just wanted to give an emphasis to what you just said. Like we discussed about this one, right? I'm also like wanted to know about this preference. How is it going on? Like we have been deploying this one, and another thing is like we have been extending MASQUE, and we have been creating creating solution based on MASQUE. So before we go into that details of extensions and the deploys MASQUE proxy, I think it would be very interesting and necessary to understand like how it's performing for you, whoever deploying it. So please, what Eric said, I completely support and I want it. So please come up with the information.
Thank you. Yeah, Lucas.
Hello, I've been involved in one way or another with the multiple deployments of MASQUE proxies, some using TCP, so Connect TCP, Connect UDP, and Connect IP. One of the things that really sucks is tooling. So is that in scope at all for what you were proposing? Maybe like there's a gap there. Is there experiences of this? Is there some scope to talk about that next time? Was one of the questions. And the other question I had is, particularly with IP tunneling, something, we have a VPN product at Cloudflare called Warp, and we announced a while back we're migrating from the WireGuard protocol to MASQUE, which is great. We want to use internet standards, as those are good reasons. The blog post explains, but something that QUIC has is congestion control, and IP tunneling over QUIC lends to nested congestion control. We've learned some things from that. I don't know if we can share them or not, but I was curious if that was in scope for the discussion, given that we try to avoid discussing congestion control in this group.
So from first to last, I think very much when we talk about tooling, that's something that we've heard in a couple of places. So definitely let's have that conversation. We can talk about if we want to update charters and things here to make sure that that's in scope, or if we want to find another home for that and combine it with some tooling that is more generic across QUIC and other areas, right? But let's have the tooling conversation and we will find a home for it, especially as people are interested in working on it, because that solves a very real problem that tends to come when you actually ship real things. So that's part one. For the other parts, yeah, I think we've been trying to steer clear from diving too deep into nested congestion control in this working group. That said, we now have a congestion control working group. We can talk about it in ICCRG. I know we've talked about nested congestion control previously in TSVWG. So when you find out more about what you're allowed to share, please do share it, and we will find a venue for you wherever that ends up.
Great, thank you very much for the clarification.
Alex.
I actually wanted to try to answer Lucas's question about nested congestion control. So Google still deploys Cubone, Connect IP's predecessor. There are still some difficulties in migrating the stack to just the use of new spellings. But in terms of performance, it should be the same. Literally all we changed around are some capsules. The original design for Cubone intentionally said, we want nested congestion control, but we don't want nested reliable delivery, with the operative theory being the endpoints should be able to do early rejection if you know you're exceeding your congestion control limits, if you have a high quality congestion controller like BBR. What I remember us finding is that if you're running QUIC over BBR, it works okay. If you're running BBR over BBR, it works great. If you're running QUIC over QUIC, everything is terrible. I don't have numbers off the top of my head, but like I do remember at some point we did some horrible hacks to basically tell the QUIC congestion controller, pretend that we actually already are within bounds and should send packets everywhere, and like the network will sort out what's what. It works. I think this is definitely an area that we could definitely use some more research and better tooling on. I don't have an opinion as to which working group it should be in. Probably not this one though, given what we have said before. But yes, we should make improvements here at the IETF.
Yeah, thank you. And especially as you dig up any history there of, hey, we deployed this and this is what we found. We'd love to hear about that kind of thing. So we will find the right set of ears to hear it, but definitely do speak it. Clicking buttons there. But yeah, so I think the last piece here, kind of as we wrap up, is we are very much chartered to adopt extensions that help with real world deployment. And so as we're starting to see more deployment of MASQUE in the wild in a lot more places, we wanted to make sure, I know that we deferred a number of extensions in previous conversations, and we said, hey, let's get the main documents out the door before we start talking about those. So I wanted to make sure that when we say we're not going to forget something later, we actually don't. So we have now officially not forgotten to talk about those things. So if we want to bring any of those back, especially as the world has changed since then, as we update them to match the new reality that we find ourselves in, this is really a good opportunity to say, hey, I'm deploying this and this is a real problem that I'm running into, and I would like to be able to pass this type of information in this place, or whatever that extension is. So I think we've seen a couple of those already from folks who are shipping things. So if you're on the path towards shipping things or otherwise running into problems, now is a great time to bring some of those there. And we've got our nice section kind of at the end of most of the meetings where, as time permits, we can talk about those ideas, brainstorm solutions, set people up in small groups to brainstorm things in a faster setting, however we want to tackle that. So with that, thank you all for all of the comments. And thank you very much, Watson, for taking notes. Are there any other things before we close the meeting for today? Wonderful. Thank you all so much.
Thank you.